k, right? Fired at an angle of 40 horizontal from the edge of the castle. If the cannonball has an initial velocity of this, what is the max height? Above the castle. So basically what I'm looking at is this, 45 degrees, 115 meters per second. I just want to know, whoop, I want to know this right here, y max. Okay, so what's the first thing you do? Crack the vector. That's numero uno. So we have v cos theta and v sine theta. Okay, so what is some hidden information? So my givens are 115 and 45. What's hidden information? Acceleration is negative 10 meters per second squared, right? Any other hidden information? There is a key piece of hidden information here. Sorry? Right there. V at the top is 0. Okay, so then if we look at what I have as my is 10 meters per second, and I have initial velocity is v sine theta. V0 to ax. I use that equation. And I'm solving for x, so I say x is equal to v squared minus v0 squared all over 2a. Now we just said v squared was 0. So it's negative v sine theta squared over 2a. And now we have to plug everything in. So it's negative, and this is going to be 115 times the sine of 45 degrees. I'm squaring that whole thing. I'm dividing it by 2 times negative 10.
The initial velocity squared.
So that gives, oops, let's go with equal. So that becomes, whoops, 165 and 82, so like 240 something? 247. 247 meters. So at what times is this at 247 meters? So what do we know? Once again, we know now the acceleration's still the same, and we know the initial velocity here. So we have y, a, and v. And what are we looking for? Y, a, v, and we're looking for t. Then we can use x equals v0t plus 1/2 a t squared. And x is of course going to be 247. V0 is going to be 115 times 0.707, so that's going to be like 78 or something. What is 115 times 0.7071? 81, look at that, I was off. So that's 81t, and then minus 5t squared. Now I'm recording. Times are 4.07 seconds. Okay, that looks weird. Technically it was supposed to be a 45-degree angle, but whatever. And we know that it took 25 seconds, so how tall is the castle? Just look at the equation that matches that. So we say x equals v0t plus 1/2 at squared. That's my equation. And luckily, I'm just going to solve. X is the same as y, so I get 81t. Oh, just kidding. Since I know t, and times 10 would be 6,250. It's 3,000 something. And then this is 80, that's 1,600. So it's like 1,300 or 1,400 meters. That's my guess. What is the answer going to have to be? No, 1,100. Okay, this comes up being negative 1,100 meters. Sorry, I was off by about 20%. And then why is it negative? Because 0 is up on the castle. So how high is the castle? You don't have to say negative. You can just say 1,100. That's how. Of course, my x equation is Vx is equal, oh, sorry, just kidding. It's x equals Vxt. And so that's going to be, I can solve this for the time, and that's going to be 250 over 81. And so that's going to be like 3 point something? 3.1 seconds. Haha. And now I know y and yt plus 1/2 a t squared. Again, we know that vy, Wes, posted. Okay. So we're just going to plug y is equal to times 3.1 plus 1/2 times -10 times 3.1 squared. So 3 squared, so that should be 10. And so then this is going to be -50, and this is the 240 again, basically, right? It's 250, so it's 200. No, that seems huge. Is that right? Wow, that's right. 203. That's humongous. So this thing's really high up in the air. I need to do this quantitatively. So what I'm velocity of the balloon is x over t. So t of the balloon is equal to x over vb. So that's 203 over 5, which gives me 40.6 seconds. 4.6, jeez. There you go. So I know that this balloon's going to be up there in 40.6 seconds. How long does it take my projectile to get there? Yeah, so all I have to do is subtract. The time that I'm going to wait to launch is going to be 40.6 minus 3.1, which gives me 37.5 seconds. So I get to wait 37.